Okay, good everyone. Still on vectors. Still on vectors. Now we'll be looking at the products of vectors. Product of vectors. Now, there are some key points that I jotted out just for easy and some questions we'll be looking at. So now straight to vectors. There are some explanations that need to be done. Now, vectors is also known as dot product. You can also say it is a dot product. So the difference between scalar dot product, or we say scalar product of vectors, or dot product of vectors. Now, on the product of vectors, we have scalar dot products. I think I said that in the last class. Scalar dot products, and we also have vector cross products. Now we'll be looking at scalar dot product first. And on scalar dot products, the difference between these two is that one, obviously we have one dot and we have using one cross like a multiplication sign. Though in mathematics everything means multiplication, these two signs mean in mathematics still multiplication. Now the difference between these two is that here we have two vectors multiplying together to give a scalar quantity. That's just the fact there. Two vectors multiply together to give a scalar quantity. But in vector cross product, two vectors like vector times vector or vector cross vector will give us vector. But for scalar dot product, two vector dot vector will give us scalar quantity. But here it will be giving us vector quantity. Now let's now go straight to the point. This is how it is denoted. And now you need to understand the fact about scalar dot product as a vector that exists between it exists when scalar dot product exists when vectors are perpendicular to each other. That's one thing I want us to understand. It exists when vectors are perpendicular to each other. We have A when A is perpendicular to B, or when we say when B is perpendicular to A, we have A dot B, and it is usually equals to 0. Please take note. That's why I put equation 1. A or point 1. Let's say let me put it as point 1. A dot B, vector A dot vector B is equals to 0 when they are perpendicular to each other. They can also be commutative. There's another point based on the characteristics of, or the characteristics or the significances of scalar product, scalar dot product. Now they are commutative, meaning that if I have it as A dot B, so far it is still multiplication, I can say it is B dot A. Now you can see what I used here as an example. This is power, and power is force times velocity. Power is a scalar quantity, force is a vector quantity, velocity is also a vector quantity. So when you multiply both of them together, it will give you a scalar quantity, same as work done. So vector times vector will give us scalar. So now they can also as well be this one. Now if I based on the commutative, I can say they are both A. If I say 2 times 3, it's still the same thing as 3 times 2, so still give me the same answer. Fine. Now going to the next, should they call it characteristics? Yes. We say A dot B plus C. A dot B, when we expand or open this bracket, this times this times this, that means that it can be distributed between other vectors. That's the meaning of distributive. So now this is a point I want us to understand. This is a very important and vital point. When we have 3 dimensions of a vector, each dimension can multiply, each similar dimension can multiply each other to give 1, but different dimension of different vectors cannot multiply to give 1, so they will give you 0. So that's another point I want you to understand here. So that's point 5. So the first one is perpendicular, commutative, distributive, similar vectors and similar dimension of different vectors, then different dimension of different vectors will give you 0. So now let's now go to the next point. Now, when solving, these are the points. When solving, so when solving some questions, you need to understand the projection of A on B. You know, vectors can be this way, they can be like this, and they can also be like this. So now, one thing I also want us to understand, when we are not looking at projection of A on B, that's what I want us to understand. A on B, you solve this way. This is a formula. This is another formula, but on the same question, but different questions. Now, projection of A on B is A dot B over B, but B on A is, now whenever you have A on, B on, so it is the one that you're having on that will be in the denominator, so take note. Then to cosine angle, the cosine angle, this is when you have to find cosine angle, this is the formula. So when you also asked to find direction cosine is different from cosine angle. This is direction, this is direction. These are extract of formulas that you should take note of. Now let's now go to this first question. Now the first question says, so that's the first question. You can see the first question. So now what you need to do here is this. You say determine the scalar products, meaning that it is scalar dot products. Now how do we do this? In the previous episode I explained how to input our questions. Now this is what I will want you to take note of. First thing, change your mode to vector. That's it. You press mode, then press it. So now you input your vector A and vector B. Note, they can change this vector. They can ask you to input vector. They can change it as vector F and vector Q or something. So just know that the first one is vector A, which is, then you press 1. Then how many dimension? 3 dimension, IJK. So you press 1 again. So now we input 3, 2, minus 1. I explained how this in the first and second episode. So you press equals to save. So from here now, after pressing the last one, so you press shift, then you press 5. So then you press, now you want to save. I've explained all this in the previous episode, just try and watch. Then press 2, then you press 2. Then we want to store the second vector, which is B, so you press 2 again. Then 3 dimension, so you press 2. Then you press 7. The first one is 7. You press 7, then you press equals to, then you press 9. So you press 9, then you press equals to, then last dimension is 2. Take note, all those things are plus 9, plus 7, plus 2. If it's minus, you have to input the minus. But this one is plus 2, so you press the plus 2, then press equals to. So here now you can now press AC. After inputting everything, then you press AC. Now we want to, the question says determine the scalar products between the vectors. So what you just need to do now is just go, then press shift 5. So you press shift 5. So you press the 5. Let's get it. So this is what you press now. What we are meant to do is to determine the scalar product between the vectors, which is a dot b, vector a dot vector b. Meaning what you need to press now is press 3, then press the shift again, shift 5 again, shift 5 again, then press 7, then shift 5 again, shift 5 again, then press 4. So now this is it. That's vector a dot vector b, which is scalar dot product. So vector a dot vector b. So then now press equals to. So the answer is 37, meaning that a dot b is 37. That's it. So for this now we have our a dot our b to be 37. Now it has, the answer is in what? Is in a whole number, which is happens to be a magnitude. So that's one thing we should take note of. That's one thing we should take note of. So that's the magnitude. That's the magnitude. So that's the magnitude. You should take note. So that's the magnitude. It has already given us the magnitude of this. So whenever you ask to find magnitude, meaning that you want to find a dot b. So that's just it. So don't forget, this one is also a projection. When you have to find a projection, this is what you are going to do. Projection of what is the question? Projection of a on b. So you make use of this first formula, a dot b, how we did the first one, then over the magnitude of b. So how do we get the magnitude of b? So this is how to get the magnitude of a single equation. The magnitude. So what you just need to do is just this 4 square plus 4 plus minus 4 square plus 7 square. So just input all this inside your calculator, then you get the modulus of b. So modulus of b is also, how do we get modulus in our calculator? This is one thing I want us to understand for this question, this second question. Now this is the formula. The formula to use for this first question is this: a dot b over modulus of b. I've explained a dot b, how you do that now, scalar dot product. This is the first one I explained. So how do you now get this modulus that you use to do the overall question? So the modulus now, you, after pressing your vector, you've input this, you've input this. Okay, let's just go and see vector 8, then let's say 1 1. Okay, let me input this as fast as possible. We have 1 minus 2, then 1, then shift 5 2 2 1. So that's 4 minus 4 7. So then press AC. Then I want to get the modulus of b. So after inputting everything, so to get this modulus b for this now, this 4 square minus 4 square plus 7 square. So how do you get it? You just come here, then you press shift this, then shift 5 4, which is the modulus of b. Sure you understand? Then you press equals to, so it will give you 9 straight. So it give you 9 straight away. So the modulus of b here is 9. So then you now do a dot b. You do the magnitude, then divide it by 9. So you get the answer for this second question. So then this one now, which is the third question. The third question is also as simple as anything. So what you just know is that the third question, it reads as this: determine the work done making an object along a straight line from P then to this. So you find the difference between these vectors, then you dot it with F, meaning that work done equals to F dot D. What? So you subtract this from this. So you subtract this from this, then you product it with this. So that's F dot D from the formula I gave you. Then this one is for angle between the vectors. Angle between the vectors, cosine angle. Then these are perpendicular vectors such as this, and this. To find the product vector, which is A dot B. Try this also. Then this last one too, try this. For what values are this perpendicular? Meaning that when you see perpendicular, it's telling you that you need to do A dot B. So try that. Don't forget to also drop your questions or your answers in the notification comment box. Subscribe, like and share. Don't forget to subscribe. Thank you. So the next episode will be vector cross products. Thank you.